Hello, everybody. It's great to be here today. I'm Suellen Ventura. I'm customer advisor at SAIS. And no matter where you are in your career, if you're a data scientist just starting, or further on the road, or passionate about analytics, or maybe thinking what can be done to effectively deliver analytics for everyone, today the discussion is for you. I'm here to share my experience on how promoting analytics adoption. So, we can start. To understand how can we promote analytics, we need first to understand the current scenario. So I want to kick things off by asking you, what are the forces that are shaping the ecosystem? Here are the 6 tips that many of you probably are familiar with and in my opinion are changing the way that how we work. First, cloud-enabled analytics. Today, every organization has a cloud strategy going forward. But understanding where analytics and data fits in the strategy is the key. The second thing here is the future of analytics is open. I have no doubt that many of you are open source programmers like R and Python. And open source is a very big part of the current ecosystem. But how can we embrace all of those different code languages? The third thing here is everyone is a data scientist. This kind of gets along with open source concept, but it also touches on the fact that many stakeholders working with data scientists, data engineers, and others in many analytics projects. The fourth thing is changing data landscape. I know that most of you have faced a challenge trying to understand where your data is, or asking questions like where we can store all of your data. Whether clouds bring vast opportunity for collection, storage, and also governance, on the other hand, there are lots of effort to deliver value. The number 5 is, and for me, is the most important thing, algorithms and techniques on leveraging more and more and the best answer quick business questions, machine learning and AI. The number 6 is IoT, analytics of things, has become more and more prevalent in today's analytics ecosystem. But now that we know about the current scenario, let's focus on analytics. And when I talk about analytics, we talk about using data to answer our key business questions like how can we identify new methods of fraud or financial crime? But it boils down to one thing: focus on analytics by empowering everyone. And not only this, to be used everywhere. And leaning into a mindset that we are better together, technology, people. But wait, if we know what do we need to do, why it's so difficult? Hmm. It's not easy to do that. It's like a traffic system in a city. There are many elements that you need to orchestrate different moving parties at the same time. So here are the 5 tips that, in my opinion, could help you to promoting analytics adoption. And I pause here to encourage you to make notes. I know that I'm talking a lot. There are five different tips to talk about, and make notes during the presentation. And at the end, I can address questions and comments. Okay, follow me. With more investment in AI and analytics, it's not a surprise that the number of the data science team in market has increased. And the challenge we face is that teams many times find difficulty in delivering because of organizational or sometimes geographic structure. And these can make very hard to data science teams to scale and support new use cases. I know that you have the same problem. Also, it highlights the needs data science teams to grow. So the question becomes, how can we enable better collaboration, both in core data science team itself, but also other stakeholders? To answer this question, here is my tip number 1. Treat analytics as a team. What do you need to consider to stop teams working in isolation? It comes down to first, we need to recognize that, oh, sorry. No. We need to recognize that in daily routines, a data scientist perform a broad range of activities. They prepare data, they build models, they need to be able to share those results with the team. They need to integrate the results into business process. And also we know that the analysis continues. It ranges from reporting to visualization, statistics, and advanced techniques such as text analysis and deep learning. And these activities require several different skills like SQL, database, statistics, machine learn. Every team member have different strengths, which end up related with these four quadrants that you can see in this slide. If you focus on individual strengths, you probably don't have enough to achieve results and bring value to the business. But generally speaking, looking at a team as a solid piece, it's likely very well balanced. So I needed to work together to leverage individual strength as we work together to deliver analytics. And second thing to consider is everyone has different skills and preferences. Different program languages provide different capabilities. Whether it's R, Python, Lua, Science, or other language, no matter, analysts should be free to choose what works better to perform these day-to-day tasks. By promoting choice in terms of interface, visual, or programming language, the number and types of employees that can work with the data expands. And with this that team can become more productive as the demand of analytics increase and overtake the ability to hire in demand data science deployer. And bring it together, these two, you really need to combine end-to-end capabilities so we can support these four quadrants and give them the choice on how they will perform on their activities. Okay, and although we have more access to more tools and techniques, data science teams are still facing more difficult, spend much time trying to access data and prepare data. And we have more and more unstructured data for countless sources, and some case without quality or also reliability. So the question becomes, how can we understand and trust data? My answer to this is invest in data, but invest in growing teams' data literacy. The ability to understand, to use, to communicate with data not only is recommended but fundamental today to achieve business goals. And this skill is what we call data literacy. Investing in analysis, initiative, and deliver analytics for everyone to base better decisions will not be effectively succeeded if people who are part of the process or impacted by it do not understand, or more than that, genuinely trust the data. And it's also investing in understanding the different characteristics of the data. While the data to support dashboard and reporting is often summarized, the data requirements to support model deployment are really quite different. It's important to look at variety because the today X systems, there are different formats of the data, and depend on the source, the application, and most of it, like I told before, it's unstructured or semi-structured when you talk about data science. Traditional data, image, videos, sensors, tweeties. Oh, sorry. Okay. I go. Yeah. Tweeties. All of these diverse of data makes up the variety and pushes the ability to process every type of data in a huge amount of it. What brings us to talk about volume. In the world of data, in the world of big data, the amount of data generated per time, in seconds, it's exponentially increasing. But because of the amount of the data is so large, companies are facing challenges in processing, monitoring, and more than that, storage. Distributed stored parallel processing are some examples on how handle with a massive volume of data that increase more and more as we go forward and now faster than ever. That can be related to velocity. Many of you have been experimenting answers more and more key business questions in less time, definitely. Today, it is necessary to process more volume of data with more variety and less time with more accuracy. And it's where computer power could help you to speed up the process. Also, we talk about value and veracity are critical to understand and take into account when investing in focusing data. And also, it's a fact that most of us remain limited and not only focus on the available data and technology to support machine learning algorithms. And again, the question becomes how can we remove that limits? So here's the number three, true data experiments. While analytics process usually start with some specific questions or hypotheses, the data and results analysis genuinely push us to continue asking new and new questions. This iterative process can bring you unexpected insights and really good data discoveries. Through scalable compute engine to effectively automatically manage computer resource, persistent data to maximize data replication and movement. We need to mix both basic and advanced building blocks that are essential for creating many kinds of a solution, including machine learning, text mine, forecasting, deep learning. I know that you are aware of all of these things. But in addition of that, automation for me is a key to success here. In terms of building replication workflows, out generation code and enable it in the application. And what is happening here is that many data scientist teams are limited by the available data and existed algorithms that they have access to. We need to, oops, yeah, now I got it. We need to remove the limits, to experiment and to conduct real and powerful data experiment focus on three pillars. In my opinion, the first one, data. It is important to work with your extended team to simplify access to all your data. Maybe access to a traditional or an emergent source. We want to be able to consume that data as quickly as we need to extreme this to the environment. The second thing that I want you to consider with removing limits about algorithms and techniques. It's crucial that the team access to more and more range of algorithms, techniques, but also tools. And make them free to ask many questions about the data and also free to pursue those different patterns that may lead them into new discoveries. This also includes give them the flexibility around being clicker or coder. Why not? We talked earlier about that. And the last piece is remove limits about computer power. It's very important to be able to run more innovative models and use more data, not just a sample. You know what I mean? This can increase the accuracy over time. And more than that, I can say that the modern machine learning algorithms are really data hungry. They need guaranteed amounts of data and a memory run engine. And a good platform could help us to scale in all of these three pillars. I know that sometimes it's too much information, and we have some time at the end to talk about your perceptions about it. Keep with me. I have two more to share with you, and I start with the number four. After we complete the experiment, uh, we can difficult. It's really difficult to link and to move to the stage where you operationalize our insights. It's not uncommon to this take several months. And the question here become how can we make insights more actionable? And how can we streamline this process so we can get more results? The answer for this question, and for me, is one of the most important. The tip number four, you or you use it or you will lose it, definitely. If you make an inquiry here, how many of you have created a new model in the last few months? You can go to the chat and answer that. But I definitely say that few of us. And even if from this group, how many of you or your models go into the production? I'm definitely sure that it's a very few of us. Because it's a common complaint among us data scientists, you know. Models are only sometimes, and if ever, deployed. From the time the tool starts to prepare data until the model is deployed, the effort hasn't created value yet. The real value of analytics comes when you deploy that insight to make a business decision. And once deployed, positive values start to accumulate. But it begins to decline as the model decays. And people no longer trust, or I can say that worse than that, they trust when it is not more accurate. And we know that deployment and managing model performance is a real challenge here. It can take, by my experience, like 9 months, 7 months, I don't know. But with time, the value from the model has dramatically degraded because the data it was based on, it's out of the date, I can guarantee you, and producing suboptimal insights. A key reason for this struggle is the lack of the tools and the process to enable to facilitate the deployment of the models. So the ability to shorten then the development cycle and sustain value by driving the last mile extremely quickly could help a personalized model faster and create business value soon. So it allows you to match your compute to demand and scale it up and out really quickly. And it also enables us to talk and to have models ops approach. This improves the quality of insights, monitoring, manage model performance in a dynamic scenario, and embedded them into the decisions flows at scales. Means you have a sustainable business impact. And people are making decisions on trusted results knowing that you continuously and effectively entertain, tuning, and improving your models. And to finish the tips, I had once in a science paper from a colleague that people trust in simple things like the time in the watch, not because they know how it works, but because they know how to read the information. And it's true. As well as having everyone the same understand about the results, making this accurate and reliable. So the question becomes, how can we democratize and explain the results of analytics? And understand the results from analytics. This can be sometimes hard and more than that, overwhelming. If you want people to embrace analytics, changing the way they make decisions, they must be comfortable with the data and the details. And one important challenge is delivering analytics for everyone is making sure that the data, the process, and the details are transparent and understandable and reliable. And I'm not talking here about part of the process like a programming language or more than a statistical model, architecture, or even technical requirement. It is more simple than that. Keep things simple. Explain the results. And when you explain analytics, be sure that you explain and interpret the data. Also, give the reason to the approach. Describe the analytics process that you use to generate the outcome, but in a simple way, please. And guarantee that a non-technical business users can understand that. This requires explanation that's not rely, remember, to mathematical or statistics backgrounds. It's simple. Make also the techniques clear because there are usually multiple algorithms and techniques, as well as numerous data sets of variable choice. Describe the specific model detail and rationale of that. And a guarantee to explain the outcomes and also articulate answers with data source. It's really important to have trust data source. And last but not least, and I think this is one of the most important here, in our talk is support all users. If a person doesn't understand or trust the data, not only they don't feel part of the team, but more than that, they won't act. So to bring this all together, I know there's too many much information. We have answers for our questions because through working and extended the team, achieving end-to-end capabilities and provide choice for everyone. But also focus on data literacy and understand the characteristics of data analytics. Also experiment, overcome the limitations, test hypotheses to find unexpected insights, and accelerate your process to have more scalability and faster assets. Increase your productivity, democratize and explain the analytics results to increase trust. With all of these, I truly believe that you can boost analytics adoptions and make sure that this is for everyone. To finish this presentation, I would like to invite you all to continue asking questions, more and more questions, and make decisions, but now better decisions based on analytics. Thank you very much to join me today, and I hope see you soon. So,
So I have a big question because it's a big topic, and that is, did you base
go
this on a
ahead.
book or a white paper? Will our link can be provided to that?
Sorry, could you
Did you
repeat, please?
base a lot of your content on a book or a white paper where a link can be provided from for it?
Yeah, science had many white papers based on that because it's then what we work and the daily routines. So yeah, we can definitely share with you and community some papers about that.
Okay, I'll follow up with the Data Science Society to make
Yeah.
sure they're included. The other thing is, as far as analysis paralysis goes, when you move from the development phase to the deployment phase of analytics and data science solutions, do you have any recommendations to fight that kind of data paralysis to get it into deployment from development?
If I have recommendation to find, it's not an easy task. I'm not saying that it's easy, and it really depends because this question it's really an open question. It really depends on the maturity of your team and data scientist team are and the problems that you are facing on. But I can say to you that based in my experience, I have no succeed if I don't have a tool and a solution to integrate all of that and supporting me because you are talking about a huge amount of data and you're talking about experiment and be ready as fast as you can to understand and understand the results of the models. So I don't know if I can answer your question really in a simple answer, but there is no rule and there is no alternatives if it's not experiment and use the advances of solutions and technology.
And so Thiago asks, are there any tidbits or hints to know how much is when you're done, so you don't keep on analyzing? Any
How much it's a come to planning? I'm not sure if I get the question.
well, any tidbits or hints on how to recognize when you've done too much? That's how you know how to
Yes.
end data paralysis or data
Yeah.
analysis paralysis.
Yeah. It's a really good question. This is what I most like in analytics. You never end your work. You know, it's kind of be improving and improving and improving and improving. And I think this is where we can change your mindset, where we can change our mindset, because it's not more related to create, develop, and go to the production and understand if you have been done a good job with your analysis and modeling to get the results. It's an iterative process. You construct, you go to the market to understand the results and going back and be these more accurate. And this is what make a new vision of how can we improve better results because it's a fast-paced environment. I cannot have more than that.
And since Dave hasn't cut me off yet, I get to ask the question about turning things into products. How many data science projects just stay as projects and never get productized?
I love that you bring that answer. I can say most of them. Uh, yeah, I don't have any uh, statistics on the top of my mind, but if I can say that I think 40% go to the production because, as I said, we are. It's kind of a. I like to do this parallel. Uh, Unfortunately, most part of us is still focused in the beginning of the process. It's kind of I love run marathons and half marathons, and one thing that I learned about that it's you need to understand and to focus on what brings value to you. And what we have been done is that we can focus in the first part of the process that it's trying to prepare data, access data, try to understand that, modeling that. And when you arrive at the part of you can deploy it, you are not up to date. You are not accurate enough to get and have a result of that. And if you change your strategy and focus on the part that you can get insights and get back the results that you are focused on, because at the end of the day you are trying to answer this question to make the decision, you can have much more advances on that.